Welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a startling paper that uncovers a major security risk in the AI models we're all starting to use. Large language models, or LLMs, learn by reading a massive amount of text from the internet. But what if an attacker secretly injects malicious documents into that training data? This is called a poisoning attack, and it can create hidden backdoors in the AI. For a long time, the thinking was that as models get bigger and train on more data, this threat would become impractical. After all, to poison a tiny percentage of a trillion-word dataset, you'd need to create a huge amount of malicious content. However, this paper, titled Poisoning Attacks on LLMs Require a Near-Constant Number of Poison Samples, turns that assumption on its head. The researchers conducted a massive experiment, training AI models of various sizes, from 600 million to 13 billion parameters. They tested a denial-of-service attack, where a secret trigger phrase causes the model to output complete gibberish instead of a useful answer. They mixed in a small, fixed number of these poisoned documents with mountains of clean data. The results, shown here in this graph, are shocking. They found that it took a nearly constant number of poison samples to successfully backdoor the models, regardless of their size. In fact, as few as 250 poison documents were enough to compromise every model they tested. This was true even for the largest model, which was trained on over 20 times more clean data than the smallest one. The vast amount of good data did not dilute or wash out the effect of the bad data as expected. This means the attack becomes more practical as models scale up, because an attacker just needs to slip a few hundred files onto the web. The researchers also showed this isn't just a one-off trick. The same principle applies to the fine-tuning stage of training. This is where a model is taught to be a safe and helpful assistant. Here, they showed that a small number of poisoned examples could install a backdoor that makes the model comply with harmful requests when it sees a secret trigger phrase. Again, the amount of clean fine-tuning data didn't matter nearly as much as the absolute number of poisoned examples. So let's recap the critical findings. First, poisoning an AI model depends on the absolute number of malicious files, not the percentage of the total data. Second, this number is surprisingly low, around a few hundred documents. And third, this makes poisoning attacks easier and more feasible against larger models, not harder. It's like finding out that the same simple key can unlock a small safe or a giant bank vault. The paper highlights an urgent need for better defenses to detect this kind of malicious data before it ever gets into a model's training set. As AI becomes more integrated into our lives, understanding and defending against these vulnerabilities will be absolutely critical. Thanks for watching Summarize Science.